All right, so we can do two things. I can either go through part of the tutorial, and I set up some VMs where you can play around with Spack if you want to. And so you can grab those if you follow the spreadsheet link that I put in Slack. So it's over here. There's the spreadsheet link. It's for the tutorial here. And then you can just put your name in here. Don't like delete somebody's name and steal their VM or anything. And you can SSH to those IPs with those logins if you want to play around in our little VM sandbox environment. Or if folks just already have questions, I'm happy to just talk or do demos. So does anybody have questions? Yeah.
Okay, so I tried installing a software WarpX using Spack.
Okay.
And I had like 10 dependencies that I wanted to install.
Mm-hmm.
When I added all of them and when I hit Spack install, it installed more than 10, like, I don't know, hundreds of things.
Did you try to install the dependencies yourself first?
No.
Oh,
so I just did Spack add
yeah.
the names, and then after doing like for 10 dependencies, I hit Spack install, and but it installed many more softwares than that, and it took hours.
Yeah. So if you put in your if you just want WarpX and its dependencies, then just add WarpX.
Okay. So after Spack, so whatever environment I create, I can do Spack install and the name of the environment, and that's pretty much it.
Yes, that's right.
Okay.
Yeah, or well, Spack install, just Spack install. Activate Spack-E environment name, or here, I'll do a demo. Let's do that. Yeah. So who wants to hear about environments? Is that sounds good? Okay, cool. All right, I'll spin that up. So get rid of this. Get rid of this. There's that. So I'm on that node. Nobody mess with my node. Can people see this size font? Okay. Okay, cool. I can hide this thing. So just to sort of show you what this would be like if you did go to the tutorial, let's go over here. I'm gonna pull it up. I think that's moderately legible. Let's see. Yeah, oh, that's 80. This is kind of. Can I do higher resolution on this screen, or is this about as high as it goes? Nope. Okay, this is it. All right. I will do it this way. Yeah, so if you go to the tutorial, and then let's go to the environments tutorial over here. Essentially, all you're going to want to do is git clone, https, github.com, spack, and clone it into your home directory like that. That's how you would get set up with it. We'll skip the basics tutorial and just go straight to environments. And it takes longer than it used to take to clone because it got bigger. So if I go into Spack here and then source share Spack setup env.sh, I should be good to go. So if I say if I do spack-h, there's all the commands you can run, and if I do spack-H, there's an even longer, really long list of all the commands you can run. Okay, so you did an environment, so you did something like this, right? So you did spack env create, I don't know, like what's your name? Okay, yeah, let's do WarpX. Okay, and if I do, Oh, actually, before I do this, I want to do. Since we're in the tutorial, if we do any tutorial exercises, there is a binary cache for the tutorial. I'm going to run Spack tutorial first, just to get the whole thing set up so that the binary cache will actually have hits. And so that's any page in the tutorial, you can run that in our image. There's a container image on the website, and you can get, in a state where it'll be quick to go through the tutorial and you won't have to wait for a bunch of builds. But he wants to build WarpX, so we may be here a while if we actually try to build it. Yeah, so Spack env list will show you what environments you have. And then, yeah, if you do Spack env activate, let's do -p WarpX, then you'll get into an environment like this where, okay, I'm in the WarpX environment and I want to add some stuff, right? Yeah, so if I do spack config get here, it'll show me what the environment looks like. So there you go. And there's no specs in it right now. Okay, So one thing you can do, so let's go through what you did. Let's try adding some stuff to this. Okay? Adios 2, okay. 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 I'm going to just leave it at those. And then let's, not warp X. You can control C Spack, we made that work. So now if I do config get, like that, Spack config get, it's going to have all the specs in it, right? That's a list of things in YAML. And all that Spack add command did was it added it added things to the list of things that we're going to build. So, okay, there is probably something you should know for this setup. If those are your requirements, so what I could have done was just write warpx there, right? And then it'll concretize warpx, it'll give me the environment I want. So let's try that. If I run Spack concretize here on the whole environment, watch what it does. It's going to go through and first it's going to bootstrap the solver. So there's this whole bootstrap phase that we go through now that we have the fast solver in Spack. It always builds patchelf from source at the moment because we don't have a fully relocatable patchelf binary, and patchelf is used for relocation. So there that goes. And this will just happen the first time you run Spack. So it's building that. So there's that. And it should hurry up and start concretizing the whole environment now. Did it actually get Klingo installed? We are still waiting on that. These AWS instances can be a little slow sometimes. Let's see if it goes. So, yeah, there we go. So now it's going to try to concretize the whole thing. You'll notice that it's parallelizing the concretization. It's trying to run 5 solves in parallel. What it's doing there is it's concretizing each of those specs you asked for independently by default. And if you want a unified environment with just like one set of things that are consistent, you can actually change this. So let's let it finish. It might be a little slow because it has to go and build an index the first time through. There we go. It's going to print out all the different things that it came up with for how to build those packages, right? So if you scroll through this, you've got Adios 2, right? There's your Adios. And you got BLAS PP, you've got Ccache, and so on and so on. And so that's a bunch of stuff. And if you run Spack find-c, which is all I'm going to run, I'm not going to actually build it, that'll show you the concretized specs. It's showing me the concretized roots, but not everything. Yeah, so there will be a lot of different builds for this. But what you can do is if you just do Spack config edit, which is basically editing your little spack.yaml there. Oh crap, there's no Emacs here? Hold on. Export editor equals Emacs NW. There we go. I made this image, so of course it has Emacs. Let's see. So now we'll go back into config edit. Oh, wow, it takes that long to launch Emacs on the instance. Great. Well, anyway. So, and Vim had nicer colors. That's sad. I should work on this really. All right. So there's this section down here that says concretize or unify false. What that means is that every one of those specs is going to get concretized independently. We're going to change this default in the next version of Spack to true. and what that will do is it will force them all to have the same dependencies. Make sense? So like that unify true means there's only one version of any particular package in your environment. It used to be we couldn't do that, so we just concretized everything separately and built what came up. But now that we have a better solver, we can unify everything. And you should use unify true if you're okay with having everything consolidated. And sometimes concretization will fail if like there literally are 2 versions of boost required in your environment, right? But you can do when possible, which is also new. And that will tell it to minimize the divergence. So if it needs 2 boosts, it'll give you 2 boosts. But if it doesn't, it'll give you 1 boost. Does that make sense? Yeah, so if you want to avoid that problem, that's what you can do. Yeah, so I would do unify true for an environment that you just want to load and run one program. Yeah. In some of our environments, like at Livermore, like we will run like a mesh partitioner and then the actual application. And the mesh partitioner may need like a different version of HDF5 than the application, because one needs the sequential and one needs the parallel or whatever. It sort of depends on what application you have. So for situations like that, you should use when possible, because then you'll get the right version of HDF5 for the two things and it won't fail to concretize. But it also won't give you 10 CMakes. So, you know, that's, yeah. Okay, other questions? Sure.
Is there any reason to not always have unified when possible?
So there's some debate as to whether, so there's currently a debate about what the default should be. Nobody really wants false. So some people seem to, false is kind of for facility deployments, where you really just want every route concretized independently. I think facility deployment should probably also use when possible. Whether we want true by default is kind of something things people are debating right now. Like, we don't really have a good way to tell users, like, it's kind of a subtle difference, right? But it's kind of technical, and so we want to pick something that's intuitive. And so the question is, like, if we make it when possible, then everything that worked before will continue working, but you'll still get multiple dependencies, and it'll be weird when you get view conflicts trying to link them into one view. If you do true, then the view linking will always work, because you'll always have, you know, you won't have two of the same package trying to go into the same prefix. But you'll fail more often than you have to. So when possible seems good to me, but other people seem to like true. So we'll see. Other questions? Yeah.
It's very simple question. I have never used this Spack, and I was trying to use it to install the HPC toolkit.
Okay.
I wanted to set some, well, to choose a specific variant.
Mm-hmm.
How should I do it to put the flag?
So if you want HPC toolkit with a particular variant, I mean, you can spec HPC. So actually, I don't know what it's called. I think it's HPC toolkit. Is John still here?
The ID is Spack,
Yeah.
info, HPC toolkit, and it tells me the variant.
Yeah, so Spack info HPC toolkit will tell you what variants there are. And so, like, if these are Boolean variants, right, these are all Boolean, so they have on and off. So all you do is, like, so which one did you want to set?
Like MPI and CUDA?
Yeah, so it would be Spack install HPC toolkit plus MPI plus CUDA.
I'm doing minus, okay.
Oh yeah, minus means off. Or tilde also means off, so we have two of those. So yeah, maybe I should do the basics tutorial. So there's, you can write this without spaces, so you can write plus MPI plus CUDA. You can also write it without spaces like this, but because we allow dashes in names, this is ambiguous. And we still have dash because if you like spaces, then tilde CUDA can be ambiguous if you have a user on your machine called CUDA. So there you go. Yeah, and then for the string variants, like if you have a package that has one, so Spack info like open MPI, if you look at this one, there is, geez, there's a lot of variants on this. Let's see. So like fabrics here, it's multi-valued. You can have any of these values. So it's going to be like Spack install open MPI fabrics equal whatever. Yeah, like PMI, or I don't know, is that one Spack in there? Well, I don't know, it's up here. What is it? Yeah, PSM, sorry, I'm screwing it up. PSM. And then if you want more, you can put a comma.
Okay. And one more question. I was also looking for the OpenCL support, and I saw in the, like if I open from the website, the document package.pi, like I don't know, from your website I opened the package recipe. Okay,
Yeah, for what?
recipe.
For which
for
package?
for the HPC toolkit.
Oh yeah, just do this, Spack edit HPC toolkit. And it'll pull it up for you.
Oh, well. Okay.
There you go.
And here there was like OpenCL variant, but it doesn't appear in. Is it like I should?
So I don't see OpenCL here.
I just Googled it and I got.
Yeah, it may be in develop. So if I go in here and I actually, you know what, I'm going to get out of this environment. So you know you can type despactivate to get out of an environment? There you go. So in here, git checkout develop.
Got it from the Spack, like from the Spack, right? Well, from the documentation of a Spack in HPC toolkit, there's the link to Spack.
Yeah, so it's in develop, but not 0.18. So it sounds like you ran. So yeah, if you just look at the documentation for Spack and you click on the package.py, it's going to give you the latest. But if you have a release checked out, it's older, right? So you're probably looking at an older version. So if I run Spack info now, like that, then OpenCL's there, right? And then if I run edit HPC toolkit, this is it, right? That's HPC toolkit. So it's got it.
So if I wanted to install it with OpenCL, what should I do?
You would need to check out develop. So you need to clone straight from develop, and then you need to do Spack install HPC toolkit plus OpenCL. Yeah.
Thank you.
Sure. Anybody else? Any other questions? I think there's one up here. Hold on. I'll get back to you.
Okay.
Very short question. So if I wanted to install Tau, I just use Spack install Tau plus like CUDA or something. That's it.
Yeah. That's the idea. It will start building it, and then yeah, depending on how up to date the Tau recipe is, you can see if it works, and then you can. So another cool thing you can do is if something breaks, so you can actually do Spack maintainers Tau, and it'll tell you all the GitHub usernames of people you can ping for help with that package. And so that actually, if you want to be a maintainer of a package, and I encourage all of you to be maintainers of packages, you can look at Tau, and there's this maintainers line in here. People just add their GitHub usernames there on the maintainers line. And then we actually, if you submit a pull request that modifies that package, we have a bot that'll go and ping all those maintainers and say, hey, there's someone submitting a pull request to your package. So you get notifications if you sign up as a maintainer. And then if it doesn't have any maintainers, or if you don't like any of the people that it lists there, or if they don't like you, you can try Spack blame Tau. What's going on here? So it looks like it's trying to run the git blame. Unknown option. Okay, git is too old on this machine to run Spack blame. So, sorry. I'm not going to APT update it or anything, or try. I guess I could install git via Spack. Let's try Spack install, or git branch. Which branch are we on? No, come on. Actually, Spack tutorial. Do we actually have it in the tutorial cache? Spack install git. If it starts building, I'm going to stop because it'll take a long time. But it's going to concretize it. All right, come on.
Is the intention there might pull the binary version?
Sorry?
The intention there might pull the binary version?
It might pull it if I have it in the tutorial cache. I actually don't know. I should probably check. It should be upstream in develop as well too. But let's see. I haven't ever done a demo of installing Git, so I'm like, should I try? I don't know. So sometimes it's slow because it's re-indexing all the packages. So if you switch between branches, you may notice that it notices that the modification date is different. And let's see, did it actually get it from? Yeah, hey, it's going pretty fast. That's nice. No binary for pcree, so it's going to have to build some stuff. I'll just let it keep going. Who has another question? Yeah.
So when you activated an environment, you saw the name of the environment, right?
Yes.
When I did that, I don't see that on my map. But when I list the environment, there's two different colors. One is activated as green and the other.
Yeah, if you want it to actually show something on your prompt, you can put -p on Spack activate -p, and it'll. If you have the shell support activated, it'll mess with your prompt. Yeah.
So, I guess while this is going, so what is like your philosophy, I guess, on sort of like facilities maybe deploying this, and then you have users maybe who've been extended that they might want beyond facility admins say choose to put on. What sort of considerations would both say the facility deployment people you consider what considerations might the users need to consider in that case? Assuming that's something you're intending to support.
So the users, so I don't know, most users I think use Spack to deploy like a thing they want to use right now, right? Or at least, they have an application they want to run or someone's told them to run. And so I don't think there's much more that your typical user needs to do other than set up some environments and run Spack install. For the facility, but I could be wrong. Users do all kinds of crazy things, right? There's also developers, right? And they have very different concerns from regular users. And so we've got some people building like shim layers on top of Spack for development. For facilities, I think the main considerations are like, what stacks are you going to support, right? What MPIs and compilers do you want to support, and how are you going to set up that matrix? For me personally, if I were doing a facility deployment, I would make an environment. I would get my whole facility deployment specified within the environment with all the compilers and MPIs and everything. There's a matrix feature for that we have. So if you look at the tutorial and check out the stacks tutorial down here, it actually shows you how to do a spec matrix. So you can do something like this, and I can make this a little larger, where if you want to build Boost and Trilinos with GCC and Clang, right, that'll do the Cartesian product of those two lists. And it'll get you an environment that builds all of that. And so you could specify a whole facility stack in a couple lines with, OpenMPI, Clang, one API, and maybe mpitch or something like that, right? And so I'd specify that. And then I think the other thing I would do is I'd figure out what my module scheme ought to look like. And so there's a whole modules tutorial over here for how to set up module stacks on top of that. And so you can set up your module layout. You can set up what things go in, like your LMOD hierarchy and so on. And I don't know. Does that answer your question, or is that? Yeah.
Getting started there, we already thought about like the naming convention, the module tree, which is kind of like the names get kind of like really long sometimes.
Yeah. So there's a whole section in here about that, about like removing the hashes from the module names if you don't like that. So like you can say, so you can have a module scheme. You can take the hashes out with hash length 0. You'll get conflicts if you have two of the same thing with that in just the default naming scheme. And so then it tells you how to like add down here. You can do projections where you can put like name, version, compiler name, compiler version for most packages, but for like Scalapack or for things that depend on Python and LAPACK, you could put the LAPACK name in into the name of the module. Right, and there's a whole section in here on how to set up like a 3-level LMOD hierarchy that uses compilers, MPIs, and BLOS implementation. So you could do kind of crazy things that sites don't. Sorry? Yeah. So I would pick some reasonable module naming scheme for sure. The default one is not very good. It's just designed so that we never get a conflict when we generate a module. And so we're using LMOD at Livermore for that. Other questions? Oh, hey, Git worked. Okay, cool. So now I can just do spack load git. And that'll put git in my path. And I can do spack blame. What was it? Tau? Is that what we were doing? Yeah, there we go. And now the newest git knows what to do with that. So come on. It's doing the history of the repo and telling you who actually messed with that package. Geez, these are slow. Did everyone decide to be on my instance? Is that what happened? Because you can see it in the spreadsheet. Yeah, so you can see who modified this package and what % of the lines are theirs and how long ago it was. And so even if it doesn't have maintainers, you can find some, person who did not volunteer to maintain the package to pester. Yeah, question?
So an issue that I have run into several times since Spack environments sets the LD library path.
Oh, we just merged that. That went away just earlier today. Yeah, so actually like over here let me go to maintainers, or hold on. This is fun. Yeah, so where did it go? Yeah, this one. Don't set LD library path on package load. So it won't be on by default in the modules or anything else. So that got merged like when? Yeah, 8 hours ago. Or yeah. So problem solved. All right. Yes. Anyone else? No other questions? Yeah.
You don't write problems of glibs. You people work with glibs.
So we sort of handle that in the Spack provenance right now by including the operating system. So if you do a Spack find like this, you can see that we put the Ubuntu version in there. And so like we're sort of finer grained than libc version in that sense, right? So a build for Ubuntu 18 currently won't just install anywhere. It needs to be on an Ubuntu 18 system. We have some rules for OS compatibility in Spack, and so like we know that like RHEL and CentOS are compatible with each other, and we will reuse binaries from one on the other from the binary cache. But we need to probably expand that list because there's a lot of sort of respins of RHEL that are compatible that we could do that. The longer term, what we want to do is actually model libc in the Spack graph. And so if you, let's see, here, let me just pull up a tutorial. Go in here. Oh, come on. Go here. Open Spack. I guess I'll go perk. So at the moment, you may notice that like if I run, here, I'll do this. Spack find dash JSON, or actually, let's see. Actually, Spack find dash L. Let's look at a simple package like zlib. So if I grab this guy, zlib has that hash, Spack find dash or Spack spec that hash. And right, that's, I wanted JSON. If I look at this, this is actually what the metadata model looks like underneath. And so what we've got on this, so these are the nodes. This one is called Z standard. This one, let's see. It has this hash down here. And you can see this is what the compiler looks like on the node in Spack right now. We don't model deeper than that in the compiler runtime libraries. So we know it's built with GCC 7.5. And we know, so like if I do Spack config blame compilers. This is a useful command, by the way. If you don't know Spack config blame, it's super helpful because it colors the file where the setting came from and tells you what line it came from for the merged config. But you can see that like this is what a compiler is to Spack. And so it's like Clang at 7.0.0. It actually has no Fortran compiler for this thing because it's Clang. It couldn't find one. It's got these two C and C++ executables, and then there's some other things that you can set on here, like the operating system and the target that the compiler should run on. And you can add extra R paths to be added when you compile with that compiler, and you can tweak the environment, like if it requires a module to run. But this is sort of annoying because it's like there's a lot of configuration to setting up compilers in Spack right now, and that was sort of intentional because we wanted you to be able to swap compilers in and out of the build easily. And so it's okay, but we're not really modeling it as a proper dependency in the graph. And so what we're working on right now for, say, like 0.19 is that compilers in Spack would become proper dependencies. And so instead of the compiler being a node attribute and us just saying, you know, we'll try not to mix them too much, we would actually know things like that the Intel compilers use GCC for their libstandard C++. And that libstandard C++ is a dependency of the things built with the Intel compiler, and that, say, if you use two incompatible libstd C++s from GCC, it'll see that as a linked dependency on the two things that were built with mixed compilers and say, hey, you can't put those two things together because they're ABI incompatible. We don't do this right now. Right now it's kind of like if you say build this thing with this compiler and this thing with this compiler and link them together, then it's on you and it's your fault. And if this happens. And so we want to get to a place where we have this model. And then if we have this, then we can put libc in the DAG. And I'd really like to make it so that you could build like a stack with muscle or glibc if you wanted to, and swap them in and out. And so the way that currently compiler specification for stuff like this is kind of a pain because you have to say things like, this package is incompatible with the Intel compiler before this version, and it's incompatible with the GCC before this version, and it's incompatible with this. So you have to write down all the compiler versions that have the features that you need, essentially. And with this, we could actually model the languages as virtual packages. And so you could say, I need C++ 17. Get me a compiler that supports it. And we could actually fulfill the virtual with a compiler dependency like this. And the other kind of cool thing for that is there are a lot of things that we use in HPC that have interfaces that are provided by compilers, like OpenMP. And so you could have a package that says, I depend on OpenMP 4.5. And then it would work just like MPI does right now in Spack, where you say, I need MPI 3 or higher for this code, and it gives you an MPI implementation. We just haven't modeled down below the compilers yet, so we're working on that. And it gets complicated because, like, I don't know if folks are familiar with this, but so like on El Capitan, which is our AMD GPU machine coming up at Livermore, there's 3 compilers in the user environment. And one of the requirements of the contract is that they be able to interoperate with each other. And so we need to be able to make an OpenMP program that uses OpenMP offload from the AMD compiler and a GOMP library from GCC and the Cray library. And the only, and the Cray compiler all together. And the only OpenMP implementation that supports all of those is the Cray one, so you have to be smart enough to know to use the Cray linker to build the whole application. So like that's the other thing this would do, is it would enable us to encode like all of the really complicated constraints like that. Like, if you want to put these 3 compilers together, you need to use that linker, otherwise everything's going to go wrong. And right now we don't really have constraints that span the DAG that way. So that was a long answer to how do you model libc, but it's a hard question. Any other questions? Yeah.
So if I have an environment and let's say it was there for 6 months and the underlying packages were updated, what is the best way to keep the dependencies up to date? Is it just like removing the entire environment to a Git pull in the Spack folder and then install it again?
So like, if one of the examples that we do in the tutorial is reconcretizing an environment. And so you can have, here, I guess I'll do that one. If I do, here, and maybe this will help. Let's see if I can actually get the tutorial up. I think the short answer is reconcretize your environment, right? So if your system, if you made an environment, you built it, it's concrete, right? But you still have that spack.yaml. You can run spack concretize-f to reconcretize the whole thing. And that'll, if you've pulled Spack since the time that you built that other environment, then it should basically give you updated versions of everything. So it would be spack concretize-f and then -- fresh. We'll tell it to fetch the new package definitions and use them in an upgrade. So that's how I would do it. Yeah. I guess I don't necessarily need to do the demo, but I could if people want to see. Are there other questions? It's hard to see questions in the back, so yeah.
This Spack with M1, I'm having some issues with Python.
So I'm going to blame Lawrence Livermore for this problem because I ordered this laptop 7 months ago, and it's an M1, and I just got it last week. So if you're having problems on M1, it's because Livermore is slow to procure laptops. But yeah, so what's the problem that you're specifically having?
It says could not find Python missing interpreter, but I already have Python that was.
Yeah, so you got a bootstrapping problem. I'm actually working on that right now. Yeah, so expect that to be fixed in the next week or so. Yeah, so you'll need to pull from develop. Right now, bootstrapping the solver on M1 is not working properly from source. And so we're hoping to have some binaries built for M1 so that you don't have to bootstrap it from source even, but it's not done yet. So yeah, hopefully that'll happen soon. Sorry, they're too new for DOE.
I generally don't use it.
Yeah. No, but it's actually, I mean, so the thing is that one of the things we noticed is that a lot of our users are running Spack on Macs. It's very important to them. So actually, like here, let me go in. I want my Mac. Hold on. If I go to the 2021 survey, we had some figures about this. Or no. Yeah, so we actually have quite a few users who use Mac OS. So like this is just a comparison of the community at large versus NNSA. So Orange is NNSA, so it's Los Alamos, Livermore, and Sandia. And it's like close to 60% of our users are actually running on Mac OS. And so we've started a working group to like keep the machine learning libraries building on Mac OS and to start keeping the stacks building there. We're trying to set up CI for it, but a lot of scientists want to run like on their laptop and on the supercomputer, and it makes a whole lot of sense. So we want to keep that working. It's just like there's all sorts of interesting IT issues when you get into like lab IT. I'm kind of hoping that now that Amazon has Mac runners, we can keep it working more often. And yeah. Other questions? No? Does anyone want me, so do people want me to do, like, we have time for a tutorial. Like, so I could do, I don't know, what am I looking at? Oh, hey, there's my Lyft receipt. Great, I'm gonna keep that off of there. So is there, here, I'm gonna just go through the sort of top level tutorials. Who wants to see like the basics tutorial? Anybody, just the really basics tutorial? Okay. Who wants to see environments? Let's see, that's less people. Anybody? Configuration's really boring, so I don't want to do that today. Let's see. I think, yeah, so let's just do basics. I'll go through basics, and I think that it seemed like there were enough people that would be useful. And y'all can just ask questions and interrupt if you want to. So here we go. Here, let's go. And so if you want to start this again, I mean, so I'm going to just do, I'm going to remove my whole Spack installation, I guess. Nah, I won't. I'll just keep using it. Spack, find. I'll wing it. So I already have a bunch of stuff installed. That's the only difference you'll see between mine and yours. All right, so this is the basics tutorial. You already saw how to install Spack. You just clone it from GitHub. I think, so just for folks who want to follow along, I pasted the URL to this tutorial in the Slack. So if you're following along, you can find everything I'm doing there. Let's see. So if you go through here, clone it, cd Spack, you check it. If you just run Spack tutorial, you'll get past all this initial stuff. And actually, I'm going to do it slightly differently. So hold on. I think I will. I'm going to log out. I'm going to log back in. I'm going to move my Spack clone for a second to just make a couple things clear. So here, I'm going to clone it. I'm not going to set up the mirrors. Actually, yeah, go there. I'm going to blow away my configuration from before. So there's a directory Spack keeps for local configuration called // We may or may not blow this away in some future release because it causes a lot of problems. But remove that if you want just a fresh install, and if you've been following along. And so now I'm going to cd here into the Spack directory, and I'm going to source the setup environment.sh. And so that'll get Spack in your path. If you say which Spack after that, it should work. The reason that we source that file is for shell integration. So Spack has useful commands like spack cd that'll cd you into a directory, or spack load that changes your environment. You need it to be a shell function for that to happen. And so this is actually setting up some fancy shell integration. Okay, so we did that. If you want to see like what packages are in Spack, if you want to see all the packages that are available, you just type spack list. And so the first time you run spack list, it'll take a while because it has to index all the packages because it needs to know which ones are virtual. We'll get into that in a minute. So it's annoying that the first time we do things, it takes a long time to index stuff now that there's 6,500 packages in it. I feel like if we wrote this in Rust or something, it would be way faster, but since we have to write it in Python, we're stuck with the long waits. All right, so there you go. And if you want to see like how many packages are actually in Spack, let's see. So if I go Spack list, yeah, you should get multiple columns, but something has a really long name up there. So we only get 2. If you pipe it to WC, you can see there's like 6,500 packages in Spack on develop. So the next thing that you want to do is, you can subselect that. So you can do spack list pi star if you want. You don't have to put a star there. If you just put pi, it'll give you all the Python packages. We have some conventions in Spack, like all the Python packages are prefixed with pi dash. All the R packages are prefixed with R dash. There are some Perl packages and so on. I guess it doesn't have to be that way, but that's what we're doing at the moment. And then, if you want to install something, you already saw me install Git, and that was pretty cool. Let's just install zlib, so a simple package with no dependencies. It's going to bootstrap again, so there it goes. It should be faster this time because it's not having to concretize an entire environment. It's going to build it, and there you go. It's installing zlib. It's executing install. And it's done. And so you can see it spit out where it put zlib. So this directory right here is just, that's one of those install prefixes that we talked about earlier. If I just ls that directory, you can see it's a normal Unix install directory like that. It's just got include lib and share. It's just put it in a prefix. And that's all it does. If you ls that and look in like the bin directory, there is no bin directory because zlib's a library. But if you look in lib, there's zlib. It's got libz.so, it's got libz.so1, all the stuff you would expect it to have. It's got a static library and so on. And so now you can use that as your zlib. If you want to get the location of something that's already installed, you can actually say spack location -i zlib like that, and it'll spit out that path. You can use that in scripts if you want to. And you can also do spack cd-i zlib to just go straight to that directory. That's one of the nice things about the shell integration. So if I go back to my home directory and continue on. So now we're going to go and add the mirror. So we have a mirror set up for the tutorial, which is in /mirror. It's local to this image. If you do that, that is where all the binaries for the tutorial live. And so we're just telling Spack that it can fetch binaries from there. The other thing that we have to do is run this spack build cache keys install trust. All that says is go out to the mirrors that you know about and see if they provide keys and just trust them. This is not the best security practice to grab the keys right out of the mirror that you're registering with. So if you want to vet this, for the public Spack mirrors, there's actually a repo on the GitHub that has the keys in sort of a second vote kind of place. So like if you're doing a facility installation and it's really important that you get the software, if you think that someone could try to compromise your access to the mirror, you can find the real keys on GitHub and within the mirror. So they're in two places. So anyway, we've trusted that, and now we're set up to use the binary cache. All that's going to do is make installations faster. All right, and so now I can start installing more zlib. So I'm going to install zlib clang. And so I said spack install zlib %clang. What that said is install zlib, but this time build it with clang. So if I run spack find now, you'll see that I've got two zlibs here. One's built with clang, one's built with GCC, and they're separate. They have separate install directories. And so this is where Spack is sort of not like your other package managers. Is that if you said spack install zlib twice on APT, it would be like, what? It's already there. But since this is HPC, we care about the excruciating details of software installations. We're going to have two zlibs. We're actually going to have way more because this tutorial goes on a bit. So if you want to see what versions of zlib are available, you can run spack versions zlib like this. And so it's going to tell you which versions it has already checksummed. And so it's saying, hey, those are the ones that I know about that I have checksums for. It also went and scraped the zlib website for more versions for you. And so it went and tried to download. It looked at like a listing of where the tarball was for zlib. It tried to find things that looked like the zlib tarball, and it said, hey, I found all these other versions. So you can install like zlib 0.8 if you want your programs to break all the time. Instead of just the regular zlib. And actually, like if you wanted to install a newer zlib than, or a different zlib than what we have, you could specify one of those other versions, and it would ask you if you want to download it without checksumming it. And it'll install a version that it doesn't know about. So like I could do spack install, I'm not going to try 0.8 because I don't even know if the build script would work. But I could do zlib at 1.2. Let's see. like 7. I think that's not in there. And it'll say, hey, I don't have a checksum on hand for that. It's not really safe because I don't know how to verify it, but do you want to fetch it anyway? I'll be like, yes, sure. I'm careless. I will install it. And so now I've got 3 zlibs. If you run spack find again, it shows you what's installed. So there's my really old new my just installed old zlib. So yeah, the @ is used to specify versions. So you could, if you had specified like zlib 1.2.8, which Spack actually knows about, it would just fetch it and install it. It wouldn't prompt you to see, if it's a version that you really meant to install. And you can be specific about that. So you can say zlib at 1. Let's just do regular zlib. And % is build with a different compiler. And you can say gcc at 6.5.0, like that. And it'll go and it'll build it with that. So it's injecting the different compiler into the build system. It's telling it to use it. It's making sure that the build works with that compiler. And it is installing lots of different versions of things. So there, now I've got 1, 2, 3, 4, 5 zlibs. The other thing that you can do is you can inject flags into your build. So if you wanted to add, like I'm going to do C flags, and I'll do CPP flags. CPP is actually the preprocessor flags, and so I'm giving it flags for both C and C++ at the same time, which is kind of cheating, but we do it in the tutorial. So if I say that, it's going to build it with GCC 6.5, and it's going to inject -03 into the installation. And so if I run that, it concretizes it again, and it says let's see, it's going to install that one from source. That's interesting. I think it's supposed to find that. Oh, I was supposed to put a version on it. Oh well, I built one that's not in the tutorial. I'll build the one I was supposed to. So if I do 1.2.8 here, it'll concretize that, and it'll say, oh, there was a binary for that one. And so it was way faster. See, it didn't build it. So now I think I have 7 zlibs. Yep, there we go. And so Spack find has a lot of options. Remember, so Spack list is available packages. And the thing to remember here is that this isn't showing you concrete configurations. These are just the names of software packages that you can install. If you run Spack find, you're really looking at the database of things that you did install. And so one thing you can do there is you can run Spack find -lf like this. And it's going to show me the flags, which is F, and it's going to show me the hash with L. And so the hash is really that's the hash of the metadata. That's the unique identifier for every installation. And so you can see that even though some of these look the same, like the zlib 1.2.8's down there, they do have different flags maybe, or different compilers, and they have a different hash. And so if you want to refer to them, you can always get information about them by putting / and the hash on the command line. So, I mean, let's try that. If I just do Spack find, let's see, what was one of the hashes? If I grab Spack find /m4, it's going to find that one zlib that has that hash. Oops. Find -l. And yeah, so that's the zlib with that hash. The hash is actually a lot longer. It's showing you the full hash, but you only have to specify a prefix. And so it's really this long thing here. It's a base 32 encoded SHA. All right, so let's do a more complicated package. If you do Spack install tickle like this, it's going to install tickle. And tickle depends on zlib. And there it goes. It's extracting that. It's going to install tickle and put it in its own prefix too. And actually, tickle got its own zlib too. So I don't know why that's so slow. And let's see, so now if I do Spack find, you can see that I've got a bunch of zlibs, and then there's my tickle that I just installed right there. If you want to actually use the tickle that you installed, which is, why would you want to use it if you're having so much fun installing it, right? So you could say Spack load tickle, and there's only one of them. So, and if you say which tickle, oops, sorry, it's tickle sh is the executable. You can see that it's got the bin directory for that tickle installation in your path now. And so there it is. So Spack generates modules for all the things it installs. You could have module loaded that thing if you had modules on your machine, but we also have our own environment support because we're doing all the other work. We might as well be able to load like a one-off package into your environment. And so Spack environments are one way to get something in your path by activating the environment. And just Spack load is a way to do a one-off package just to get it in your path. And it's kind of like module load. If I had said something like Spack load zlib, what do you think is going to happen? It's going to yell at you because it says, hey, there's like 7 of those because you're nuts. And so which one should I put in your environment? You would have to be more specific and say like zlib/g4 to specify the one with that particular hash. And so you could do that. It'll get it in your path, and it's not going to do much because zlib doesn't have any executables. But I could do end grep zlib now and see what it did, and you can see that like one of the things it did is it stuck that zlib in my CMake prefix path. And so if I want to build with CMake, the things that I loaded via Spack are going to be preferred for finding dependencies when you build something with your CMake build. Yeah.
Yeah, a question about architecture dependent build. You just showed that there are many different packages of the same program.
Yes.
So we have a cluster, which have many different kind of nodes for the build. So in that case, is there a automatic way for Spack to query the underlying architecture and then load correct?
Yeah. So actually, if we don't. Are you getting a bunch of, is Spack yelling at you because you have multiple architectures installed?
We have maybe 3 or 4, and each have 4 different architectures, and the installation depends on what building is, if you are aware of the different architectures.
Right.
A lot of times people just build one, and then if they want to, this one is not perfect architecture element, so you build many different ones, but which one to choose automatically? Since we don't know which node we are going to allocate.
So if Spack does know how to figure out what architecture your machine is, so if you say Spack arch like this, it'll tell you that this is a Skylake AVX 512 node, right? And so that's the microarchitecture. What I could do is, here, I can actually demo this. So like if I try, if zlib will actually build, let's see, Spack install, we'll build the most optimized zlib ever. Zlib target equals Skylake AVX 512, right? So I can actually build it like that. That syntax exists. And if I do Spack load zlib now, the way to do this explicitly is I can actually just use this same spec again if it's unambiguous. So I could say Spack load, Spack load zlib with target Skylake equals AVX 512. You can definitely do this explicitly and get one into your path. What I'm not remembering is if we actually solve the problem where if your 3 architectures are incompatible, that it picks the best one by default, right? Like, or that it picks the right one by default. I'm not sure if it'll yell at you if like you have a PowerPC zlib installed next to an x86 zlib, if it looks at your machine and sees what the host architecture is and loads the right one. So it may not do that properly, in which case I'd stick it in environments and wait for us to fix that bug.
Yeah, because you can always specify the target if you know the target.
Yeah.
But when you submit a job in a script, you don't know which target you're going to use.
Yeah,
so we have to write a small script depending which architecture is allocated.
Yeah, we should, we could, so Spack, I think there is, hold on a second. So there is Spack load -- first. And you can load, and I think currently this is a dice roll. So it's going to give you like the first one maybe by hash. We could make that smarter and give it like, we could have like Spack load -- best or something, or make first best, and give you like the most preferred one, like which might be the newest or the fastest target architecture that you can actually run or something like that. But we don't do that right now. Yeah. But that's a good question.
Yeah, that's also assuming you have to do all architecture.
Yeah. Yeah, that's right. So one way to limit it is to have an environment that sort of limits the scope of the combinatorial complexity that you're going to run. But like you said, if you have something that you really want to be able to run on different architecture nodes and have it pick the optimized one, we don't have great runtime support for that with the load stuff. You have to kind of figure out what the most optimized thing is yourself right now. Yeah, that's true. So I agree with that. That's a really good point. All right, so if you want to know what you have loaded, you can do spack find -- loaded, and it'll show you just the stuff that's loaded. And you can do spack unload -a to get rid of all the stuff that you have loaded in your environment. And so that works pretty much like a module system. You just don't need modules for it. Okay, so I guess I'm going to keep going through this. If I want to refer to a specific hash, like so if I do spack find -d, I'm going to do spack find -dl tickle right now. It's going to show me the hashes, and it's going to show me the dependency graph, or well, a little tree visualization of the dependency graph of the thing I asked for. So I asked for tickle with dependencies, and it's showing me that this tickle depends on that zlib, and that this one has this hash, and this one has this hash. And so you can refer to each of those independently. If you want a tickle that's built with a different zlib, you can always do spack install tickle, and you use a caret to talk about dependencies, right? And you can refer to the hash of one of the installed zlibs. So if I do spack find -l zlib, I'm going to look around, and I'm going to say, like, I really wanted, is that one not in there, 2f2? Yeah, it's this one. So I really wanted this particular zlib 128 that was built with GCC 7.5. And I will build, so I'll go 2f2 like that. You could put zlib /2f2, it doesn't matter. The hash uniquely identifies it is all that it's really looking for there. If you ask for like tickle /2f2, that's not a tickle hash, it'll yell at you. But if you put the right package there, it's fine. So that'll say install tickle with exactly that zlib. So you have some pretty strong control over which thing you're building against, down to the hash. So it's going to build that. Let's go over here. So spack find -ldf will give you basically everything that's installed with the hashes and all the dependencies listed. If you add a P on there, it's going to give you their installation paths as well. So that may be helpful if you want to run spack find -p to see where everything lives. You can do that. Let's do some more complicated packages here. I only got 5 minutes, so I guess I'll get one HDF5 in. So here we go. If we go and install HDF5, it's going to concretize that. And it's going to give me HDF5 with all of its dependencies. So let's go in here. And it's going to go and grab the binaries for all of those. We're going to make this binary installation a lot faster, so I'm hoping that this will be more exciting in future iterations of the Spack tutorial. Right now, the relocation is slow. But the advantage is that we can install anywhere. So come on. So do people know what relocation is? Do folks know what I mean by that? So when you build a package, you install it to a particular prefix. Usually you can't just take a Linux binary and move it to a different place on your hard drive, because like it won't know where to find its dependencies. Strings may be embedded in the binary that are hard-coded to particular paths. So we actually take those and rewrite them to point to a new path when we move things around in Spack. So it's finally gotten to HDF5. It's unzipping it and relocating the binary to the new path. And it will, if it will hurry up. Let's go.
Or whatever settings that are like set on HDF5 by default, is that kind of what's typically included?
Yeah. So if you do spack find HDF5 now with -d or DL, let's do that. Or DL, yeah. So there's your DL VF for variants. If you add V on the spack find, it'll show you the variants. So it's got like MPI, it actually has MPI disabled for this one. And it's got plus shared. Right, so I believe HDF5 has MPI on by default, so I'm actually not 100% sure why we grabbed a one without MPI here, unless I'm showing something wrong. Yeah, so if you want to see what the default looks like, just run Spack spec, and if you have stuff installed, run -- fresh to get a fresh concretization of it, HDF5, and you can see sort of what you would get if you weren't reusing from the build cache. And so, and it will show you what it would install. So that's what spec is for. So like this is the default setting for HDF5, yeah. So normally it would have OpenMPI. It would have HDF5 here. So HDF5 would depend on this CMake, and so on. So that's showing you basically what it's getting, just considering the package files and not trying to reuse stuff that you already have installed. Yeah. I think I got a weird HDF5 installation because I had a bunch of other things installed from before. So, so if I wanted to install one with MPI, I would just say Spack install HDF5 plus MPI, like that, and it would prefer to install with MPI. So it'll give you different concretization. So I think that's about all we have time for. Is there anything in particular that y'all want me to show up here, like is for user interface or anything? Any questions about like just the basic usage on the command line? You saw a little bit of environments from his earlier question. You saw a little bit of the basics. There's a whole lot more in the tutorial. So if any of you want to come to one of our like tutorials at SC, it's like a 7-hour tutorial, and we go through all the different sections.
Can you show a pretty dependency graph for everyone?
Yeah, sure, I can do that. I may. Oh, actually, I don't have GraphViz around right now. Yeah, so I don't have GraphViz right now, so I don't want to wait for it to build. But yeah, I can show you how to generate one.
I mean, I already know. I just figured that might
Yeah. We could definitely do like Spack. So you can do Spack graph HDF5, and it'll show you an ASCII version of the dependency graph. So I stole the graph rendering algorithm from Git that shows you all the branches on the command line. And so it's going to concretize HDF5, and come on. This is the problem with solvers. And yeah, so with this visualization, you can see like there's HDF5 at the root. All of the edges are colored, and you can see like this is not the tree that we usually show. This is all the connectivity. And so like you can see that HDF5 depends on zlib, and it depends on CMake directly, and so on. And then it's actually showing you the edges between things. If you can read that, like it's still a little bit of a pain to read all that. If you want a nice dot graph, you could do Spack graph -- dot HDF5, and it'll go concretize it again and give you a dot file that you can render with GraphViz. And that's how I generated all the pictures for the presentation. And also, if you try to, some algorithms for E4S takes a really long time to render with dots, so it's kind of pushing the limits of what we can actually throw into dot solver. So if you want to crash dot, you can actually run Spack graph -- static for the full graph with like everything in Spack. And so I've tried to graph like all 6,500 packages, and it just like it hangs GraphViz. It doesn't. Yeah. But yeah, so this is just normal dot output. It's a digraph. It's giving you all the nodes and putting labels on them, and then it's got the edges down here. And so you can take that and throw it into GraphViz and render it how you want. Other question?
To install Spack on Theta or on any of the ALCF exams, can you load it as a module, or do you follow the tutorial for installation?
I would clone it for now. What I would like to have in a future version of Spack is something where you can just module load Spack and have it installed to your home directory by default and reuse some standard libraries from LCF. We're working on that setup. It's not as easy to do as we would like. And so like I think in some future iteration of Spack, essentially, it won't write to its own install prefix. You'll throw it on the machine, and it'll install to your home directory by default, but the facility could install things that could be reused by everybody. And so we're working on that. Right now, you can do that with upstreams. So if you know where OLCF Spack is, you can register it as an upstream, and Spack will try to reuse the packages that are there. So you can set that up. Look up chaining and upstreams in the docs for that.